Second-generation devices can now communicate at significantly faster speeds. In this video, we'll review the VINT communication protocol, discuss the improvements that second-generation products have introduced, and provide information about whether this will impact your system, and if so, how to choose an appropriate communication speed. The VINT communication protocol refers to the serial communication between a VINT hub and a VINT device. Data is transmitted bidirectionally via the white wire on a Phidget cable. Second-generation VINT devices have hardware and software improvements that allow for significantly faster communication speeds. As we can see, first-generation devices had communication speeds of either 10 kilobits per second or 100 kilobits per second. Second-generation devices can now communicate at speeds up to 1 megabit per second. This higher speed results in faster data rates and reduced latency when sending commands to devices. Next, we'll take a look at whether the VINT communication speed will impact your system. You can easily determine if you need to consider the communication speed of your device by visiting the Specifications tab for your product. Here, you'll see a spec for maximum VINT communication speed. If your speed is 100K or less, it's not configurable and you won't need to consider it for your design. If your speed is 1 meg, it is configurable and you may need to consider it for your design. The next thing to consider is whether the VINT hub you're connecting to is first or second generation and whether the port you're connecting to supports high-speed communication. Second generation VINT hubs will have a shield present on their enclosure. They'll also have a megabit icon present on any ports that support high-speed communication. If you have a high-speed device that's capable of 1 megabit per second, but the hub you're connecting to does not support high-speed communication, your device will be locked to 100K and you won't have to consider communication speed in your design. You can also use the Phidget control panel on Windows to help you identify your system. The control panel will indicate which hub ports and devices are capable of high-speed communication. Here, we can see port 0, 1, and 2 are colored red and show a high-speed label. Also shown in red is the PhidgetSpatial, which supports high-speed communication. If we view the device properties for the PhidgetSpatial, we can see that it's communicating at 1 megabit per second with the hub. Next, if we unplug this hub and plug in a hub 0, we can see that there are no longer any red high-speed ports available. The PhidgetSpatial is still a high-speed device, but if we view its properties, we can see that it's communicating at 100K and setting the communication speed is no longer available. You can also use the Phidget22 API to determine if your system supports high-speed communication. A code example is available online. Next, we'll talk about selecting a communication speed. All second-generation VINT hubs have auto set speed enabled by default. This means that the VINT hub will automatically select the fastest communication speed possible. For most devices, this is acceptable and no further consideration is required. Some devices, however, like the PhidgetSpatial MOT0110, have data rates that are impacted by the VINT communication speed. We can demonstrate this by using the cable length calculator that's available on the Specifications tab of the product page. If we have a speed of 100K, we can see that the minimum data interval of the device is 8 milliseconds. If we set this to 1 megabit per second, we now have a minimum data interval of 2 milliseconds. When designing systems for devices like this, it's important to understand the relationship between cable length, communication speed, and data interval. For example, if your application required a data interval of 2 milliseconds, ensure you're selecting the appropriate cable length to achieve that, which in this situation would be 2.5 meters or less. Finally, if your device has a data rate that's impacted by the VINT communication speed, like the MOT0110, consider manually setting your communication speed before deploying your system. Auto-set speed may occasionally select a slightly lower speed due to cable length edge cases. By manually configuring your speed, you can guarantee that you'll always have the expected communication speed and data rate for a given cable length. Thanks for watching this video. For more information, check out our other guides surrounding second generation VINT upgrades and Phidget cable links.